Hello friends, in today's session we are going to talk about the different methods that we use for the factorization of algebraic expressions. So now let's start with the first method, which is factorization using common factors. So in this method what we do is we first take each term of the expression and we find out the non-reducible factors of that term, of each term of the expression. So now when we write the expression again, we write each term of the expression as a product of its factors. Now after doing that, we now use the distributive property of multiplication over addition and subtraction, and we separate out all the common factors from all the terms. Now this gives us the final expression as the product of factors. Now we'll see what we've said with an example so that we can understand it, what we are trying to say. So let's first take the expression which we have to factorize. The expression is 24p square qr plus 18pq square r plus 9pqr square. So now we'll first take each term, the first term being 24p square qr, and we'll write it as a product of its factors. So if we see that 24 has factors 3 multiplied by 2 multiplied by 2 multiplied by 2, and then p square can be written as p multiplied by p, and then we write q and r. So that's how we write the first term as a product of its factors. Now we take the second term, which is 18pq square r. Now we write this term also in the similar way, and it becomes 3 into 3 into 2 into p into q, and then multiply that with r. And now we take the third term, which is 9pqr square. So again write this term as a product of its factors, which makes it 3 into 3 into p into q and into r into r. So now we can see, looking at these terms which are now a product of their factors, we can see that 3 is a common factor in all of these terms when we write the term as a product of their factors. And we also see, if we look at 2 is present in the first term, it is present in the second term, but it is not present in the third term. So we cannot take 2 out as a common factor. Now if we look at p, we'll see that p is also present in all the 3 terms. So we can take p also as a common factor. We again see that q is another common factor in all the terms. We see q in all the terms. So we take q also out. And then similarly, r is another common term which is present in all the 3 terms. So we take out r also. So we take out 3 into p into q into r, which are the common factors in all the 3 terms. We take that out and we write the remaining part of each of these terms in the brackets. This is using the distributive property. So in the first term we are left with 2 multiplied by 2 multiplied by 2 multiplied by p. In the second term we are left with 3 multiplied by 2 multiplied by q. And in the last term we are left with a 3 into r. So now we can write this. Now since we were writing this as the product of factors, now we don't need to write it like that. When we do a final factorization, we can join them together. We can find one common product and then write them in the normal form. So the common factors which we've taken out have become 3pqr, and this 2 into 2 into 2 into p becomes 8p 3 into 2 into q becomes 6q, and 3 into r becomes 3r. So this expression 24p square qr plus 18pq square r plus 9pqr square can be written as 3pqr multiplied with 8p plus 6q plus 3r. And so we can say, looking at this notation of the expression, we can say that 3p, q and r are the factors of this term, and the expression 8p plus 6q plus 3r is also a factor of the given expression. Now let's take a look at the second method that we use for factorization of algebraic expressions. This method is called factorization using rearranging and grouping. Now, some expressions can be factorized by grouping the terms which have a common factor. Now in this case, what we do is we take the expression and we rearrange the terms so that we can find a common factor from the grouped terms and then take it out. Say for example, we have this expression to be factorized ax plus bx plus ay plus by. Now in this, we group the first two terms together and we take out x as the common factor from there, and it becomes x multiplied by a plus b. And the third and the fourth term we take together and we take y as the common factor, and we are left with y multiplied by a plus b. And now we use the distributive property in that to make it x plus y into a plus b. So we can say that ax plus bx plus ay plus by can be written as x plus y multiplied by a plus b. And x plus y is one factor and a plus b is the other factor of the given expression. So now let's look at how do we actually do that in some other expression. Now terms of some expressions need to be rearranged. Now in the first example that we talked about, we did not have to rearrange the terms. The terms were already placed in the same order and we just grouped the first two terms and the last two terms together and took out a common factor. But in some of the expressions, the terms are not placed in that order, so that is where we need to rearrange the terms before we can do the grouping. So let's take an example. The expression is ab multiplied by x square plus y square plus xy multiplied by a square plus b square. Now we first open the bracket to get four separate terms. We get ab x square plus aby square plus xya square plus xyb square. Now instead of using, if we group the first two terms together, we will get what we already had in the original expression, but that is not helping us to factorize. So what we do here is we take the first term and we take the third term because they have a common factor ax, and we rearrange them, we bring them together, and we take the second term and the fourth term together. So we rearrange and then group them. After grouping them, we take the common factor out, which is ax in the first group. Ax is taken out and then we are left with bx plus ay, and in the second group we have by as the common factor with bx plus ay again remaining in the brackets. So now after doing this, we use the distributive property as we have discussed in the previous example, and we get the final factors like ax plus by into bx plus ay. So these are the two factors of the given expression. Now let's move on to the third method of factorization of algebraic expression. This method is called factorization by splitting the middle term. Now first thing to understand is this method is usually used in expression with three terms. We are saying usually, but that's not That does not say that this is the only place that we use it at. It is used at other places also. If it is used in conjunction with another method, then this may be used for expressions more than 3 terms also. So it is very important to understand that this is not the only usage, but we are saying usually that's where we use it. Now for expressions of the type ax square plus bx plus c, we split the term bx. See, the name of the method says factorization by splitting the middle term. So what we're trying to do here is, the middle term in this case is bx. We split the middle term bx into b1x and b2x in such a way that b1 plus b2 is equal to b, and b1 b2, that is the product of the two uh, splitting terms b1 and b2, becomes equal to the product of a and c. So let's see it with the help of an example. But the first thing that we do here is that we split the expression, and the expression now becomes ax square plus b1x plus b2x plus c. Now we group these terms. Once we've split the middle term, and we made the new expression, we group the terms in such a way that we get the common factors. This is where we use the first or the second method that we've already talked about. Now let's see what we're trying to say with the help of an example. Now we need to factorize x square plus 6x plus 8. Now looking at this, we are not able to find a common factor from these terms to factorize it directly. So what we do here is we split the term 6x into 2x and 4x. Now you can see that 2 plus 4, that is b1 plus b2, is equal to b, which is 6. So 2 plus 4 is equal to 6, and 2 multiplied by 4 is equal to 8, which is a multiplied by c, where a is 1 and c is 8. So we get 2 into 4 is equal to 8. Now 6x could have been broken up into 3x plus 3x also. But you will see that 3x plus 3x is giving you 6x, but 3 multiplied by 3 is not giving us 8. So it is not meeting the criteria that b1 plus b2 is equal to b, and b1 multiplied by b2 is equal to a into c. So that is why we have the only option of breaking it into 2x and 4x. Now we group the terms. We group the first two terms together, and we group the last two terms together. After grouping, we can take out x from the first group, and we can take out 4 from the second group, and we'll see x plus 2 is common amongst the two groups after factorization. So what we do now is again use the distributive property and make it x plus 4 multiplied by x plus 2. So we can say x square plus 6x plus 8 is equal to x plus 4 and multiplied by x plus 2, or in other ways x plus 4 and x plus 2 are the factors of the given expression. Now we have another way of doing the factorization of algebraic expression using the identities. We've already discussed identities in the algebraic expression session, so we'll not talk about what are identities, but we'll see how do we use them for factorization purposes. Some expressions can be directly factorized using the standard identities. An expression of the type x square plus 6x plus 9 can be directly factorized using the identity x square plus 2ab, a square plus 2ab plus b square is equal to a plus b whole square. Now if you match the given expression x square plus 6x plus 9 with a square plus 2ab plus b square, we'll find that a is equal to x and b is equal to 3. So this expression becomes x plus 3 whole square. Similarly, some identities of the type a square minus 2ab plus b square is equal to a minus b whole square can also be used to factorize the given expression. To factorize, now let's take another example where we have to factorize x raised to power 8 minus y raised to power 8. We can clearly not use the above two identities that we've talked about. The identity to be used here is a square minus b square is equal to a minus b into a plus b. So now if we match the given expression with this identity, we know x raised to power 4 is equal to a and y raised to power 4 is equal to b. And we get this expression as x raised to power 4 minus y raised to power 4 multiplied by x raised to power 4 plus y raised to power 4, and this could be further factorized if possible. Now some other identities that could be used for factorization are a cube minus b cube is equal to a minus b into a square plus ab plus b square, and second identity a cube plus b cube is equal to a plus b into a square minus ab plus b square. So these are the identities which could be commonly used for factorization of the expressions. Now let's see one more method that we use for factorization of algebraic expressions, but this is very specific to the cyclic expressions. So this is called factorization of cyclic expressions. Now let's first understand what are the cyclic expressions. Now let's first take an example. Expression of the type a multiplied by b plus c plus b multiplied by c plus a plus c multiplied by a plus b are called cyclic expressions. Now let's try to understand what is so special about this expression. Now this expression, if you see it, the first term, which is a multiplied by b plus c, is in a way similar to the second term and third term, with the difference that you can obtain the second term by just cyclically replacing each alphabet. So here in the first term, if we replace a with b, b with c and c with a, we get the second term. And similarly, if we replace a with c, b with a and c with b, we get the third term. So this is cyclic in nature. So these kind of expressions are called cyclic expressions, where we can just get the repeated terms, the second term and third term and fourth term and so on, if there are more than one variables present in that. If we can get this type of the next terms just by cyclically replacing the letters, these type of expressions are called cyclic expressions. So now they have a special way of factorization. In such expressions, we first open the brackets to get the expression with basic terms. So we get, in this expression, if we see, we'll get AB plus AC plus BC plus BA plus CA plus CB. So we'll open the brackets in these kind of expressions, and then we'll arrange the terms in ascending or descending order of one of the variables. So we'll see that, okay, there is a first variable, say a, which has a power of 2 or a power of 3 or a power of 4 as the highest power. So we'll arrange that as the first term, and then we'll arrange them in the descending order. Or we could do it other way around. We'll take the a to the power 0 in the first as the first term, and then arrange them in the ascending order of their powers. We'll then use the method of common factor to factorize the expression. The common factor method might be used more than once to do the complete factorization of such expressions. So it may not happen in the first step itself. You may have to repeat the step a number of times to get the final factorization of the expression. We'll see how we do that with the help of an example. Now the example here is we have to factorize a square multiplied by b minus c plus b square multiplied by c minus a plus c square multiplied by a minus b. Now let's see what do we do to factorize this expression. We first open the bracket as we talked about. So it becomes a square b plus a square c plus b square c minus b square a plus c square a minus c square b. Now, if we rearrange them, as we said, we'll rearrange them in the ascending or descending order of the power of one variable. So in this case, we choose a as the variable. So a to the power 2 are clubbed together, and then we keep the terms with the power 1 of a, and then we keep the terms which have 0 power of a. So we get a square b minus a square c minus b square a plus c square a plus b square c minus c square b. Now we see clearly that in this first group we can take out a square as the common factor, and we get b minus c. In the second, where the power of a is 0, we can take out minus a and we get b square minus c square. And in the last, we get bc common and we get b minus c. Now, breaking down b square minus c square using the identity, and then we put it as a product of b minus c and b plus c. So as we see here. So now we can clearly see in all the terms b minus c is the common factor. So we take that out and the remaining expression becomes a square minus, it becomes minus a multiplied by b plus c, which I have opened in the single step. So I made it minus ac and plus bc. Now again we rearrange them in the reducing order of the power of a. So we put the a square here and we get the two numbers with the power 1 for a, and then we keep the last term as this. Now in this we take out a common from the first two terms and we get a minus c in the bracket, and we take out minus b from the last two terms and we get a minus c. There we get minus b common and then a minus c. So now again using the distributive property, we get this as a product of b minus c into a minus c into a minus b. So these are the three factors that are there for the given expression. So that is how we factorize the cyclic expressions. Now let's talk about the division of polynomial using factorization. So these are the different methods that we use for factorization. Now using this is division of polynomial using factorization is one of the usage of factorization. Now some polynomial to polynomial division can also be carried out using factorization. In our algebraic expression division session, we've talked about how do we do polynomial to polynomial division using long division method. So now we are saying that, instead of using the long division method, if you could do certain division using the factorization, it may be a faster and a smarter approach wherever possible. It may not be possible at all the places, but wherever possible, yes, this is definitely a much faster and a smarter approach. So let's now take two polynomials. One is 10x raised to power 4 minus 30x cube minus 180x square, and the second is 5x square minus 30x, and we have to divide the first expression by the second one. Let's see what do we do. Now in the first expression itself, we can clearly see that we can factorize it to 10. We can bring out 10 common, and we can also bring out x square common. So after factorization, it becomes 10x square multiplied by x square minus 3x minus 18. And the similar thing we do here in case of the denominator, where we bring out 5x as the common factor and we divide it with, and we get x minus 6 in the brackets. So now after doing that, we can write 10x square as 5 into 2x square, and we can also factorize x square minus 3x minus 18 using the splitting the middle term method, and we make it x square minus 6x plus 3x minus 18, and the denominator remains as such. So now here, looking at this term, using the splitting the middle term method, we can factorize it into x minus 6 plus 3 into x minus 6. We're just taking the common factors out as we've discussed in the previous slides. And now we have, in this step, we've cancelled 5x from the denominator with the 5x from the numerator. So we get in the numerator 2x multiplied by this expression. Now we factorize this expression, which was x square minus 3x minus 18 to x plus 3 multiplied by x minus 6. And in the denominator we have x minus 6, which can be cancelled out with the numerator. So we get, by cancelling x minus 6, we get the final result, which is 2x into x plus 3. So now this is an easier, faster and smarter approach of doing the division in this case where the division by factorization is possible. Now let's try to understand what is 0 of a polynomial. The value of the variable for which the value of the polynomial becomes 0 is called 0 of the polynomial. Now this, why are we talking about 0 of the polynomial in factorization, is because we can find the 0 of the polynomial using the factorization method. If x minus a is a factor of the given polynomial, then a is the 0 of the polynomial, which means, say for example, we take the expression x square minus 4 and we factorize it as x minus 2 into x plus 2. Now if we need to find out the 0 of the polynomial, we know that either of the factors of the polynomial, which is x minus 2 and x plus 2, so either of these factors need to be 0. So that means x will either be equal to 2 or equal to minus 2, and these two values of x will result in this polynomial becoming 0. So that is why these two values of x are called zeros of the polynomial, and they can be found using the factorization method. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.